In this lecture, we are going to learn about named reactions in organic chemistry. There are many named reactions in organic chemistry. One of them is Cannizzaro reaction. This is very important reaction in organic chemistry. This is given by aldehydes which do not have alpha hydrogen atom. They undergo self-oxidation and self-reduction, that is disproportionation reaction, on heating with concentrated alkali. The concentrated alkali could be either sodium hydroxide or potassium hydroxide. In this reaction, one molecule of the aldehyde is reduced to alcohol and a second molecule of aldehyde is oxidized to carboxylic acid and salt. So one molecule is reduced to alcohol, the second molecule of aldehyde is oxidized to carboxylic acid salt. Let's see an example. Formaldehyde. Formaldehyde is HCHO. One molecule of formaldehyde and another molecule of formaldehyde plus concentrated KOH. This is concentrated alkali. On heating, it gives methanol and alcohol. Methanol is CH3OH. This is a reductive product and it gives potassium formate HCOOK. This is carboxylic acid salt. This is oxidative product. So this is Cannizzaro reaction. Let's see another example. Benzaldehyde. This is C6H5CHO plus one more mole of benzaldehyde C6H5CHO plus concentrated sodium hydroxide. This is concentrated alkali. So benzaldehyde can be written like this: benzene ring, to that attached CHO. On heating with concentrated sodium hydroxide, it gives C6H5CH2OH. This is benzyl alcohol, reductive product, and it also gives C6H5COONA, that is sodium benzoate, carboxylic acid salt. This is the oxidative product. This is Cannizzaro reaction. Now let us see what is an aldehyde and see what is alpha hydrogen. Aldehyde is an organic compound containing carbon oxygen double bond, that is C double bond O. This is called carbonyl group. So C double bond O is called carbonyl group. In aldehyde, the carbon is attached to one hydrogen atom. This is a must, and it is attached to another hydrogen atom or a carbon of an alkyl group. So carbonyl carbon should be attached to one hydrogen atom. This is a must. Then the second bond of the carbonyl carbon is either attached to hydrogen atom or a carbon atom of an alkyl group. So this is the example. This is the carbonyl carbon, C double bond O. It is written in green ink for you to understand better. This carbonyl carbon here is attached to a hydrogen atom and to another hydrogen atom. This compound is formaldehyde. Generally it is written as HCHO. The carbonyl carbon here is attached to a hydrogen atom and another hydrogen atom. So this is an aldehyde. Okay, now let us see another aldehyde. This is acetaldehyde. CH3 CHO. Here the carbonyl compound C double bond O is attached to a hydrogen atom, and it is attached to a carbon atom of CH3 group. So here the carbon is attached to a hydrogen atom and the C atom of an alkyl group, that is CH3. So this is acetaldehyde. So the conditions are the carbonyl compound group should be attached to a hydrogen atom and a carbon atom of an alkyl group. This is CH3 is the alkyl group. This is generally written as CH3 CHO. This is acetaldehyde. Now let us see benzaldehyde. C6H5OH, C6H5CHO. This C double bond O is the carbonyl carbon. This is attached to a hydrogen atom here and a carbon atom on the benzene ring. So it is attached to a hydrogen atom and carbon atom on benzene ring. So the carbonyl carbon is here is attached to hydrogen atom and carbon atom of an allyl group, that is C6H5. This is generally written as C6H5CHO. So this CHO is the functional group of aldehyde. Functional group is CHO. Now what is alpha hydrogen? Hydrogen which is attached to a alpha carbon is called alpha hydrogen. What is alpha carbon? Carbon adjacent to the functional group CHO here is the alpha carbon. Okay. Now let us see formaldehyde. This is the functional group. CHO is the functional group of formaldehyde. There is no carbon adjacent to functional group. So no alpha carbon. Since there is no alpha carbon, there is no alpha hydrogen. This hydrogen is not alpha hydrogen because alpha hydrogen should be attached to a carbon atom. There is no carbon atom here, so it is not alpha hydrogen. Since there is no alpha hydrogen, formaldehyde gives Cannizzaro reaction. Is that clear? Now let us see the example of acetaldehyde. Acetaldehyde is CH3CHO. The functional group is CHO. This is the carbon adjacent to functional group. So this is alpha hydrogen. Alpha carbon is this carbon of CH3 group. So alpha carbon is there. Alpha carbon is attached to 3 hydrogen atoms. So it has 3 alpha hydrogen atoms. Hence, acetaldehyde does not give Cannizzaro reaction because Cannizzaro reaction is given by aldehydes which do not have alpha hydrogen. Acetaldehyde is having 3 alpha hydrogen atoms, so it does not give Cannizzaro reaction. Let us see the example of benzaldehyde. C6H5CHO. This CHO is the functional group. The carbon adjacent to this functional group is located on the benzene ring. So there is alpha carbon is present here. Alpha carbon is present on benzene ring, but it has no hydrogen atoms attached to it. So there is no alpha hydrogen. Since there is no alpha hydrogen, benzaldehyde gives Cannizzaro reaction. Let's see the easy way of writing Cannizzaro reaction. Easy way of writing Cannizzaro reaction. Now, let's consider this formaldehyde. This is 1 mole of formaldehyde. This is another molecule of formaldehyde plus concentrated NaOH. HCHO plus HCHO plus concentrated NaOH on being heated will give CH3OH methanol. This I have written as HCH2OH. Then HCOONA. This is sodium formate. This is carboxylic acid salt. This is the oxidative product. This is the reductive product. This is the easiest way of writing Cannizzaro reaction. Now let us see how it is done. HCHO plus HCHO. First write HC and then this, take this hydrogen and add to it. It becomes CH2. Take OH from alkali and write here. So this becomes CH3OH. This is the reductive product, alcohol. Now here HC is left. Write HC. There is one O and there is one O here. Write both the oxygen here. HCOO. Write Na from here to here. So this becomes HCOONA. This is sodium formate oxidative product. So that is the easiest way of writing it. Add both this hydrogen as well as this hydrogen to this alcohol group, HCH2OH. Add both the oxygens here and write Na. This is the oxidative product. Let us see about Benzyl. C6H5 CHO. This is Benzaldehyde. Then another C6H5 CHO, another molecule of Benzaldehyde plus concentrated potassium hydroxide. On being heated, we'll get benzyl alcohol. So take this hydrogen and write to this here. So add to this CH, C here. This becomes CH2. Take OH from here and attach here. So CH2OH. This becomes alcohol. Now for the next, you write C6H5 and C is left here. Write the C. O is there. Write O. Take the O from here, first molecule, and write here. Take potassium from this and write here. So it becomes potassium benzoate, carboxylic acid salt. This is the oxidative product. So this is the reductive product, benzyl alcohol. Oxidative product is potassium benzoate. So if you are asked in the exam about Cannizzaro reaction, write the definition and write these two reactions. This will be enough. Okay. Formaldehyde plus concentrated NaOH giving methyl alcohol and sodium formate. And write this other example. Benzaldehyde plus concentrated KOH on heating gives benzyl alcohol, C6H5 CH2OH and C6H5 COOK, carboxylic acid salt. This is enough. Now those of you who want to learn about the mechanism of reaction, you can learn from here. Let's see the mechanism of reaction in formaldehyde. Formaldehyde is HCHO plus concentrated NaOH on heating gives methanol, that is methyl alcohol, and sodium formate, HCOONA. Let's see the mechanism. Formaldehyde is written in first molecule of formaldehyde is written in green ink. This is written as HC double bond O H. That is HCHO. This is formaldehyde. This is the first molecule of formaldehyde in green ink. Okay. We are heating it with sodium hydroxide. Sodium hydroxide ionizes into Na plus and OH minus in aqueous solution. This OH minus is called nucleophile. So the first step in the reaction is nucleophile attack on carbon. This oxygen being more electronegative will attract both the electrons of the pi bond towards it. So this carbon becomes positive. Hence the nucleophile attacks this carbon to become HCOH, O minus and H. So this nucleophile attacks the carbon atom and becomes a negatively charged ion here. In the second step, hydride ion is transferred to second molecule of formaldehyde. How it is done, we'll see. Now these two electrons from O minus will return and form a bond here. So the negative electron density increases on this carbon atom, as a result of which this hydrogen atom along with the two electrons of the CH bond will go and attack the carbon atom of second molecule of formaldehyde. This is hydride ion. Hydride ion means H minus ion will attack this carbon atom, and those two electrons of the pi bond will migrate to oxygen, which is more electronegative. As a result of which we get HCHHO minus. This is alkoxide ion, and this molecule upon losing hydride ion becomes formic acid, HCOH. This is formic acid. So we got an alkoxide ion and formic acid molecule. In step 3, proton transfer takes place from formic acid to alkoxide ion. This hydrogen atom leaves the bonded electrons behind and migrates as H plus ion, that is proton, to this negatively charged oxygen atom. As a result of which we get methanol, HCHHOH, that is CH3OH. This is methanol. It is nothing but reductive product. Reductive product because hydrogens are being added here. So it is a reductive product. As a result of losing proton, this molecule formaldehyde, formic acid, becomes formate, HCOO minus. This is a negatively charged ion, formate ion. In the step 4, the sodium plus ion of sodium hydroxide comes and combines with formate ion to form sodium formate, HC double bond O Na. This is sodium formate. So this is the oxidative product or carboxylic acid salt of sodium. So this is Cannizzaro reaction given by, this is the mechanism of Cannizzaro reaction given by formaldehyde. Now let us see benzaldehyde. Benzaldehyde C6H5CHO plus C6H5OH plus potassium hydroxide upon heating gives C6H5 CH2OH, that is benzyl alcohol, and C6H5 COOK, that is benzyl formate. Sorry, benzyl, it is called potassium benzoate. Sorry, potassium benzoate. So this is the oxidative product. Let's see the mechanism. So benzaldehyde is written as C6H5 C double bond OH. Okay. Potassium hydroxide, that is concentrated potassium hydroxide, ionizes into K plus and OH minus. This OH minus is the nucleophile. So this is the attack by nucleophile, step 1. This oxygen, being more electronegative, will pull both the electrons of the pi bond towards it. So this carbon becomes positive, positively charged. Then this nucleophile attacks this carbon atom and attaches itself here. So this becomes C6H5 COH H and O minus. Now this is not a stable ion, as a result of which these two electrons will return back to form a pi bond here. So the electron density on this carbon increases, as a result of which this hydrogen atom attached to this carbon will take the two electrons of the CH bond along with it and goes and attacks this carbon atom of another benzaldehyde molecule. This is hydride ion H minus. The first molecule of benzaldehyde is written in green ink and the second molecule of benzaldehyde is written in blue ink for you to understand better. So after losing this hydride ion, this becomes benzoic acid. C6H5 COOH is benzoic acid. Now this hydrogen goes and attaches to this carbon atom of the second molecule of benzaldehyde. These two electrons will move to this oxygen and it becomes negatively charged ion. So this becomes alkoxide ion C6H5 CH O minus H. This is alkoxide ion. So here we get benzoic acid and alkoxide ion. In step 3, proton transfer takes place from benzoic acid to alkoxide ion. This hydrogen atom of this OH group leaves behind both the electrons of the bond, OH bond behind, and goes out as H plus ion, that is proton, and is abstracted by this O minus ion, as a result of which it becomes C6H5 CH2OH, that is benzyl alcohol. This is the reductive product. After losing this proton, this benzoic acid becomes benzoate ion, that is C6H5 C double bond O minus. This is benzoate ion. In step 4, potassium, which was left behind by OH minus, this potassium ion K plus ion combines with benzoate ion to form potassium benzoate. So C6H5 C double bond O minus will combine with K plus ion to form C6H5 C double bond K. This is potassium benzoate. So here we have seen one molecule of aldehyde is getting converted into alcohol, which is reductive product. Another molecule of aldehyde is being converted into carboxylic acid salt. That is, so this is Cannizzaro reaction. Cannizzaro reaction is nothing but a self-oxidation and self-reduction reaction, that is disproportionation reaction given by aldehydes which do not have alpha carbon atom. This is opposite of aldol condensation reactions where alpha hydrogen is necessary. Here the condition is alpha hydrogen should not be there on the aldehyde. Then only it will give Cannizzaro reaction. This is a very important reaction of aldehydes. So this is often asked in the exams. Please learn how to write the Cannizzaro reaction in the easiest way, and then if needed learn the mechanism. Thanks for watching. Please subscribe, share and like and comment. Thanks once again.